my topic is, in fact, landslides itself. Landslides, but from geotechnical engineering perspectives. So today, I'll just talk about these issues, and I will later introduce you some of the things that I have seen in Japan and in Nepal too. Today's workshop is it's all about geohazard risk management. So basically we'll focus on landslides. Not me, but the BGC team, the technical team from BGC will be instructing you all these issues. And our Nepalese experts are also there to teach you the Nepalese scenario of landslides and all those geohazards, not only in Nepal, but in the Himalayas too. So with this, I'll just start something about like why geohazards, right? Everyone probably knows about these issues in Nepal and the Himalayas or in any mountainous country in the world. And why by Nepal Geotechnical Society? Because Nepal Geotechnical Society, it was established some 25 years ago in 1994. And ever since we have been working to do something in geotechnical issues, but you see in Nepal, it's not really a developed field of civil engineering because we don't really have those designing parameters and all those things. We do, whatever we do is very basic of geotechnical engineering. So that's our effort, that we want to make geotechnical engineering issues more listened by the government as well as by the society. That's how Nepal Geotechnical Society is working. That's why we are having this workshop today to talk about geohazard risk management. And what are the goals? The goals are just to tell you what geohazards are and how to manage those risks out of those geohazards. And I hope in 3 days you will learn a lot from Canadian experts as well as our Nepalese experts. Because today we don't have many instructors here, but from tomorrow probably there will be many from Nepal too. And how frequent will it be? So Mandeep said that we plan to do it at least once in a year. Not only in geohazards, but in geotechnical related field. And what are we doing in this workshop? So you can see the program, and there will be 3 days fully packed program, and hands-on work exercises are also there. And the instructors will be lecturing you. They will tell about all those issues everywhere in the world. And this is the content. And then the primary objective is, this is not by me, it was like the committee decided to have this objective to empower Nepalese professionals. I don't know how many professionals you are here, but professionals with their abilities to contributing to geohazard assessment and management, and ultimately to improving the country's geo-disaster resilience. So this is the prime objective of our workshop today. And content and all those issues are enhanced understanding of geohazards, skill development for engineers, hands-on learning, and promote knowledge excellence. The workshop content itself is like understanding landslide, what understanding landslide is. Focus on case studies, shift from detailed technical explanation of landslide types to real-world examples showcasing different causes and triggers. And the risk management for landslides will be like decision-making process, BGC workflow, because they are very experienced in all these issues, so they will tell us their experience, and then data collection and analysis, and performance-based design. So this will be the main content of this workshop, and then we'll have hands-on activities too, practice sessions and case history discussions, and presentations by both Nepali experts and BGC, and maybe other that means the experts in the relevant field. So this will be the overall flow of the workshop. And I know most of you know about all these issues because people say natural disasters. I don't say, or we don't say now it's natural disaster. We don't say, because every disaster is related with humans. So the human intervention is the main cause of disasters. Naturals are events only. They are not disasters. So we make disaster, we cause disasters. So that's why that's natural environment and there is human society, right? So the natural environment maybe towards अलिकति भोल्युम लो गर्नु मिल्छ इकोइङ भइरहेछ नि There are many steep slopes, especially when you go to mountainous areas, and there definitely is rain as well. There are volcanoes, there are snowing and snow melting, seismic activities, typhoons and rains, or cyclones and rains, and low pressure, especially if you go to ocean or sea, there will be low pressure effect of all those tides and all those things. And then in human society, you will have all these things because you have to build all those things that are good for you or that you want, right? You make the dams and reservoirs, you cut the slopes, because if you don't cut the slopes, there will be no problem at all. Not at all, but mostly there is no problem. But if you cut, there will be a problem. And if you fill, the earth fill is also a problem. And when you go for agriculture farming in mountainous areas, there's also a problem. And there will be land development and urbanization, and there is river dikes that we build to train the rivers, and that will be a problem too. And then urban development and risk. So we raise the risk because we go for developing our urban facilities. Okay? So these are the things. So now imagine of this situation. You have a house just in the vicinity of a slope. Okay? So how much the risk for this house to be damaged by slope failure? And what are the governing factors? And see, these may be the factors that may affect this house. The risk of landslide or risk of geohazard, local geological and geomorphological environment, precipitation and seismicity, state of human activities and intervention, proximity to steep slopes, failure size, disaster preparedness state, how the people living in that house are prepared for disaster, okay? And disaster risk perception, how much they know about risk. So these are the issues that control the geohazard risk of this particular, or landslide risk of the particular house. So landslide prediction, if you talk about landslide prediction, is it really possible to predict a landslide? Okay? So the basic elements in prediction, always to predict a disaster, to predict any kind of geo-disaster, we need at least location and size or scale of that disaster and the time. And location is almost possible in case of landslide disaster because we can identify those locations. And size and scale is also possible because if you know the natural conditions, you can almost predict the landslide. And time is, it depends on the size and the scale of triggering factor, such as rain or earthquake, are possible before a few hours to few days. If you have rainfall, if you create an earthquake, then probably you can say that there will be a landslide event. Okay? And so I said predicting the location is almost possible. It's because geology, geomorphology, high earthquake activity areas, volcanic activity area, high precipitation area, these are the areas where you can have landslides. Okay? And the geology may be like, you can say, if you have granitic zone, then probably that may be vulnerable to all those failures, right? And sandstone or shale zone or volcanic ash zone may be prone to landslides. If you go for geomorphology, like in average, from 20 degrees to 60 degrees, the slopes are vulnerable to failure. Or if you have earthquake, then probably intensity greater than 5-, that's in Japanese scale. Or in Mercury, you can say it's more than 7 or 8. Okay? And if you have volcanoes ash deposit slopes. And rain may be like, if you have continuous rainfall more than 200 millimeters or hourly rainfall of 30 millimeters. So that may be very dangerous for slope failure. So these are the issues that are considered while predicting things. And the size and scale, it depends on geology, geomorphology, size of natural drains, valley, size of triggering factors, etc. Right? And that may be like, regarding the time, it's very difficult because you cannot predict earthquakes. You can predict rainfall, but not accurately. Okay? Now, precision is very high, but it's not very accurate. Sometimes you fail. So that's like earthquake, difficult to predict. Precipitation is predictable, but a few days in advance. Heavy rain cautions, warnings. I'm talking about the Japanese scenario. I don't know the world. are possible, and possibility of landslides are predictable. Evacuation orders will be issued, and people can evacuate and go somewhere else. So, for example, this is one area. I made it in Japanese, I'm sorry. So that's it's an example of Japanese hazard map for landslides. There are many failure-prone slopes in the mountains, right? And that will be the source of the debris coming out of all those valley area, and that may damage your urban area or any settlement. So the risk increases when you are closer to the failure spots or the debris deposit area. It decreases when you go farther from those areas. So this is how you can plan for risk assessment. And risk assessment or risk of all those things, there are different factors like what is the size of a slope failure, how far it is, and what is the size of the stream, and how many people live in there, how many roads are there, how many railways are there. So all these things govern all those risk assessment. Okay? And these are the things that we use in predicting the hazards, geohazards, landslides, anything. So these are called hazard maps. All the hazard maps, they consist of only the location and the size of the disaster, but not time. Okay? So that's why we prepare these hazard maps. And this is probably, if you know about risk is all about like this. This is a chart made by Glade in 2002. You have hazard and damage. Okay? So if damage and hazard both are very high, then that will be very high risk. So it is how it is explained. And risk is basically probability and consequences. Okay? So the consequences, the risk is function of hazard, exposure, and vulnerability. So these are the things that we consider while evaluating risk. And these are all, I'll just skip it. And the exposure elements are like this: people, built environment, natural resources, economy. So all these things are the vulnerable elements and exposure elements. And there will be impact and vulnerability. So impact, maybe there are different ways of hazard can affect the community. So lives, structures, infrastructure, and facilities, economy, historical values, etc. And the vulnerability will be like this too. So these are the things that we consider while assessing the risk of any disaster. So let me explain a little about what I do and what the scenario is in Japan. So landslide hazard in mountain or hill areas, Japan is an example. So Japan is this one. They have 4 big islands, and I live in this part of the Japanese archipelago. Tokyo is here, Osaka is here, and I live here in this different island, smallest island of the 4 islands. And this is the scenario. Japan is about 70% mountains and hills, and this is the area where I live. This is called Shikoku Island. I live in this particular city called Matsuyama. And the Shikoku region is about 80% mountains and hills. And I'm talking about this because Nepal is also about 83% mountains and hills. So this has similar geomorphological and geological conditions as Nepal. And Japan has very heavy precipitation. The maximum is about 4,000 millimeters, and geologically it's very complex. There are 4 plates colliding to each other and generating lots of earthquakes almost every day. Minor earthquakes every day, major earthquakes once in 10 days or 10 years or 20 years, or mega earthquakes in 100 to 150 years. So these are the Pacific Ocean Plate, Philippine Sea Plate, and the North American Plate. So they collide with the static Eurasian Plate. And as you can see, Pacific Ocean Plate moves towards northwest by 8 to 10 centimeters a year. And the South Philippine Sea Plate moves about 5 to 6. So there will be a relative movement of Pacific Plate as well as this Philippine Sea Plate. And they collide with the Eurasian Plate, and they generate very heavy earthquakes. And major landslide types, probably if you go through the textbook, you can see all these landslide types. Because if you go to western part of Kathmandu or eastern part of Kathmandu, you see so many landslides, and you don't even identify which landslide is which one, because there are so many different things. And it's very difficult to identify a landslide when you go to the field. Okay? And this is one huge landslide, about 2.5 square kilometers, that happened in Japan in 2008. So it was, total length was 2 kilometers and width was about 1.5 kilometers. And it's a very huge one that failed because it was in muddy stone area. The muddy stone, it basically comes out of the volcanic ashes too. And so this was the aerial photograph. And so this is the Japanese landslide map. So they have mapped all those areas too. They know what are the landslide topographies are and where the location of landslide may be in future because of earthquake or because of rainfall. So a role of existing potential landslides and potential infrastructure development hard, because we in Nepal too, we have so many landslides, because I don't know the definition, exact definition of landslide in Nepal and in Japan are similar, but landslide is, it may be active, it may be passive, it may be like rain-induced, it may be earthquake-induced or human intervention-induced, many different things are. But landslide is a very comprehensive word. We have many different types. So the hurdles may be prospective infrastructures, maybe like we can have highways and roads, tunnels and bridges, high dams and rivers, etc. Right? And the hurdles and long-term effect. Avoiding existing landslides in road alignments is nearly impossible, especially if you talk about Himalayas. It's very difficult. You cannot avoid those landslides. Tunnels may be one option, but tunneling may also reactivate landslides. Reservoirs may induce mega landslides and so on. So these are the problems that we face. So preventing the damage and long-term effect. Okay? Landslide and roadside slopes are the issue that we deal very often in Nepal and the Himalayas too. So landslide stability, forces involved in stability, creeping mechanism, material involved in its physical and shear strength properties, stabilization techniques, avoiding reactivation due to infrastructure development, for example, roads, tunnels, bridges, dams, reservoirs, etc. So these are some of the examples you can see, because not in Nepal, but all over the world, because there are huge landslides that are caused by human activities, especially cutting the slopes or filling work or even some agricultural stuff. And these are in Japan. The latter top one was in 2016 because of earthquake, huge landslide occurred because of earthquake. And there are so many problems as well. And recently in 2024, 1st of January, there was a big earthquake in northern Japan, this part. Okay, so it's called Noto Peninsula, and there are so many landslides because of earthquake as well. And so these are the scenarios that happened, and this is, you can see that the road has been blocked because it was a tunnel here, and that moved because of the landslide. So there are different problems. And a landslide is managed very well in Japan. I don't think many, because they have lots of problems, so they have to invest a lot in managing landslides. And this is a landslide map of Japan. So you can see all these black spots are landslide topographies. Okay? So these are the landslide mapped areas in different parts of Japan. And this is landslide that you can just explore in the internet, and you can search for landslide maps too. So if you see in Shikoku area or in the northern part, so these are the landslides in my area. And these are the landslide in, this is the earthquake hit area, and there are so many landslides here. And so this is landslide map. They already have landslide map. They have mapped everything there. So these are like, some of them are very active, some of them are not very active, but they may move when there is earthquake or when there is a very heavy rainfall. And this is also the same mapping area, and this one is a map of landslides, and you can see this is the area. You can see people living on landslides. Okay? So this is a creeping landslide that moves only about 2 to 3 centimeters a year. Only 3 centimeters a year, but what is the effect? But if it goes for 10 years, then probably that's 30 centimeters, right? If you leave it like that, then 30 centimeters of movement of landslide will damage everything there. Roads, houses, and all those power lines. So people need to be secure, safe. So they have, this one is the real landslide photograph. Okay, so this is the same. This is one village in Japan. There are only 200 people living on landslides, and they need to be safe because, and they have to invest a lot to protect or to manage that landslide and risk of disaster. Okay, so this is all those photographs, and this is one hand sketch made by one of our friends because we build roads on these landslide areas as well. If you go to any mountainous part of Nepal, you will see all road alignments over a landslide. Okay, because there are so many steep mountains, and they have, because all our mountains are in mountain building process. So once you push the material upward, some of it comes down automatically, okay, naturally. And that's the reason why Sagarmatha doesn't go up and up it will not go up, because it goes up to 8,848 meters, but once it goes 1 meter above that, probably some material comes down again. So that's the limit of this rock mass in the world. Okay? And so this is the map that we made from Kathmandu to Pokhara back in 2005 or 2006. You can see so many landslides, so many faults out there. So this is a landslide mapping of all those creeping landslides as well as slope failures. As this was, now you can see Narayanganj-Mugling Road is being destroyed, damaged every year because of rainfall and all those things, right? Because there are so many landslides, already existing landslides, because we have aligned that roadway through the landslide areas. So this is the real scenario of all those landslides. So another part of the roads, another part of the roads, another part of the roads. And finally, if you look at the vicinity of Kathmandu, like about 60 kilometers vicinity of Kathmandu, then you can see so many landslides there too. And so these are the sort of scenarios of roads in Nepal. And this has been damaged recently. This is the Sinduli-Badibas road, built by Japanese too. And there are many different things what we imagine of building a road. You need lots of structures, right? Whether you go for cut slopes, or you go for tunnel, or you go for field work. So there are the certain elements that you have to use when building roads. And there are other things also that we may go for a retaining structure or even for protecting the slopes. But do you think we do all these things about? But no, because these Japanese people did in this Sinduli-Badibas only. We don't really use all these things here. So instead of cutting slopes or instead of filling the slopes, we go for like this kind of structure, which is very expensive for us. And so our practice of road building in Nepal's case is now, we focus more on road bed only, the road bed only, not to the slopes. So slopes and slope protection works is not really attended by us, the geotechnical engineers in Nepal. And so no to minimum work, right? We don't really go for that. We go for gabion retaining work or stone mason retaining walls, bioengineering, which are not really effective in managing slopes for a longer time, only for 1 or 2 years. Okay? So these are the things that we use in Nepal. Repair and maintenance is very important too, because you have to go for maintenance or repair. Okay? So regular patrol, checking, pavement maintenance, drainage cleaning or clearance, structural health monitoring, guardrail maintenance, guard mirrors. I recently went to, yesterday I went to Kanti Highway. So it's all damaged because we don't have any protection of slopes there. So slope mapping and all these things are now, modern things are happening. We have to manage all those slopes. If you go to Hong Kong, you will see each and every road slope identified and by specific ID. Slope, number, this and that. And they have all that computerized system. They manage every slope out of their control room. Okay? And so these are the things that, because this is in Nepal, what we could do is like this. Okay? And this is retaining structure. We just collect the stones, build a retaining wall, right? So instead of doing that, we can go for a little bit of longer, durable or sustainable slope protection work. So, and definitely building a tunnel is alternative to slope cutting, right? But it's not very feasible in Nepal's case. For developing nations, it's very expensive. We cannot go for that. You can see these cut slopes, but if it's not rain, if you have less rain, you don't really go for tunneling. You can cut as much as you want, okay, or wish. If you go to California, you will see all those unprotected slopes. That doesn't mean that we don't also need unprotected slopes, because we have lots of rainfall in Nepal. California doesn't have rainfall. They don't, because their rain is not enough to induce slope failure. Okay? But our slopes are very, very prone to little rain. So that's how it, because these are the examples that we go for, cut slopes and all those deep cutting. But Japanese do not cut slopes like this. They will build tunnel instead. Okay? So these are the things that we practice in Japan. And this is, I'm not going to talk about who is controlling the time. Over? So, am I going to get some more time later, or this is the end?